Hi boys and girls, welcome to our mathematics lesson. It is good to be with you today. I am Teacher Sarves from Sekolah Menengah Jenis Kebangsaan Chunhua Confucian. Today we are going to learn about isometric transformations. Please have your grid papers and a pair of compasses with you. We are going to do construction. By the end of today's lesson, you should be able to recognize transformations and translation. Describe translation by using various representations, including vector form. Determine image and object under a translation and solve problems involving translation. Recognize reflection. Describe reflection using various representations. Determine the image and object under a reflection. Geometrical design is created by transformations on certain shapes, curves, or lines to get a creative and a thematic design. Pupils, there are many ways geometrical designs in things or products that we use. Can you name them? Great! We have tiles in our homes, patterns, square designs on shirts, also the shapes on the butterfly wings. It represents a natural transformation. Before going, what is a transformation? Correct. Transformation is a match of points in a plane. When the object moves in a transformation, each point of the object follows the same pattern of movement. Before changing the position, it is identified as an object. After changing the position, it is identified as an image. The shape of the object and image does not change. Now, pupils, is this a transformation? Yes. Can you explain why? Good. It is not a transformation because it changes the shape of the triangle. Well, when the appearance of the image changes, then it is not a transformation. Well, what about this object and image? Is it a transformation? Correct. It is a transformation because only the position changes, but the shape remains. Pupils, now let's look at this diagram. A, B, C, D, F, E is an object, while N, P, O, R, Q, M is the image under a transformation. Can you mention the image of point C? Correct. The image of point C is O. Now, can you name the image of line AE? Good. That's right. The image of line AE is NM. Well, if the object and image have the same shape and size, regardless of the orientation and movement, we call it congruence in transformations. Pupils, can you identify if these pairs are congruent? Can you explain? That's great. These shapes are not congruent because their sizes are not the same. Now, can you tell me whether these pairs of shapes are congruent and why? Correct. The shapes are congruent because the object and image are of the same size even though the position and orientation are not the same. Girls and boys, now let's get into our discussion on one of the transformations, which is translation. Let's have a look at the movement of this object. What can you observe? Yes, the object moves and it does not change the shape and size. A translation is the transfer of all points on a plane in the same direction and through the same distance. It does not rotate or change in size. The shape and size of the image is the same as the object. Well, pupils, how do we describe a translation? Let's watch this video.
Okay, Bernice, slide 3 to the right of x-axis.
The pupil moves 3 steps to the right.
Slide 5 steps to the left of your x-axis.
The pupil moves 5 steps to the left.
Okay, Jingwan, walk 4 steps down your y-axis.
Now, the pupil moves 4 steps backwards. Yes, translation involves the movement or slide to the left, right, upwards and downwards. Pupils, translation can also be represented using the symbol of vector x, y, where x represents the horizontal movement and y represents the vertical movement. Besides that, moving to the right is represented as a positive value of x, whereas moving to the left is represented as a negative value of x. Furthermore, moving upwards is represented as a positive value of y, whereas moving downwards is represented by a negative value of y. Well, pupils, how do we describe a translation in a Cartesian plane? Now, let's have a look at the movement of point P from O in the diagram. What can you observe? Right. The point moves from coordinate 0, 0 to 3, 4 and represented by an arrowed line, which determines the direction OP, where OP is a vector. Thus, from O, the point moves 3 units to the right and 4 units upwards. Therefore, the translation of point P from O is equal to 3, 4. Let's look into another example. The point O to P moves 4 units to the left and 2 units upwards. Therefore, O to P equals to -4, 2. Now, pupils, can you describe the translation for? Yes, good. The point moves 7 units to the right and 5 units downwards. Therefore, OP equals to 7, -5. Great! Girls and boys, now can you determine the translation of the diagram? Let's check the movement for each vertex. From point A, move 5 units to the right and 2 units upwards. from point D, move 5 units to the right and 2 units upwards. From point B, moves 5 units to the right and 2 units upwards. From point C, moves 5 units to the right and 2 units upwards. Therefore, the translation is 5, 2. Now, pupils, please try this question. Draw the image of object A in the diagram with translation 6, -3. Done? Let's check. Move 6 units to the right and 3 units downwards. Similarly, for each vertex, move 6 units to the right and 3 units downwards. Move 6 units to the right and 3 units downwards. Well, now draw the image. Label this as A prime. Denotes the image of A under translation of 6, -3. Is your answer correct? Great! Well, pupils, now can you determine the coordinates of the image if coordinates of the object and translation is given? Let's check. Determine the coordinates of the image A if given the translation of point A is 4, -5. We need to move coordinate A 4 units to the right and 5 units downwards. Yes, the coordinates of the image labeled as A prime is 1, -3. Girls and boys, in addition, there's an alternate method to solve this problem. You can write in vector form such as the coordinate of the object A, -3, 2 plus the translation 4, -5 equals to 1, -3, which is the coordinate of the image of A. Good. Now, let's solve a problem involving translation. A flower pot is moved from position B and undergoes the translation of -5, -3. Can you determine the coordinates of the flower pot before the movement? Given that the image of the flower pot B prime is -3, -2. Pupils, can you try? Yes. First, write in vector form. Let the coordinates of B as x, y. xy plus -5, -3 equals to -3, -2. Now, pupils, we bring the coordinates of -5, -3 to the right to find the coordinates of x and y. Let's solve. -3 minus -5 equals to 2 and -2 minus -3 equals to 1. Hence, the coordinate of point B is 2, 1. Pupils, we can check our answers. Coordinates of the flower pot B 2, 1 undergoes a translation of -5, -3. Therefore, coordinate x moves 5 units to the left and 3 units down. Yes, correct. The image of the flower pot is -3, -2. Well done, pupils. Well, pupils, let's look into reflection, which is another form of transformation. In the diagram shown, we could see the object and the image of a shape. The object is flipped along a line, which represents a mirror, or we call it the axis of reflection. If a mirror is placed vertically along the line of x equals to 8 to produce the image of object A, then the image obtained is seen as A prime. Thus, the axis of reflection is x equals to 8. Now, pupils, what happens in reflection? It is similar to looking at our face in the mirror. The image of our face in the mirror is the result of reflection. Reflection is a transformation that occurs when all the points on the plane are reversed in the same plane on a line. The line is called the axis of reflection. Now, let's observe the object and image. We can identify the object and the image on the opposite sides of the axis of reflection. The object and its image have the same perpendicular distance from the axis of reflection. The shape and the size of the image is the same as the object, but the orientation is reversed as it is flipped towards the axis of symmetry. Girls and boys, now try to determine whether the following patterns show the orientation of a reflection. Let's observe. The line occurs as the axis of reflection or the mirror. Is it a reflection? Good, it is a reflection. The shape remains the same. The size is the same. And the orientation of the object and image is reversed. Therefore, this pattern shows the orientation of a reflection. Now, pupils, what about this pattern? Assume that the line is the mirror. Well done! It is not a reflection. The shape remains the same. The size is same. However, it is not an orientation of a reflection because the image is not reversed. Therefore, this pattern does not show the orientation of a reflection. Pupils, the pattern Q prime is the image of the object Q under a reflection. Can you describe the reflection? Now, let's try this together. The distance between x-axis and the object is 2 units. X-axis is the axis of reflection. The shape and the size of the object and image of the pattern is the same. Besides, the object and its image have the same perpendicular distance from the axis of reflection. Pupils, let's observe the orientation. Yes, there is a reversed orientation of the object. Therefore, we can conclude that the object Q is reflected in the x-axis. Well, pupils, now can you describe the reflection for the diagram given? Q prime is the image of Q under a reflection. What do you observe? Excellent. The distance between a point from y-axis and the object is 4.5 units, and the distance between another point from y-axis and the object is 4 units. Similarly, all the points of the object are flipped in the same plane along the y-axis. Thus, the y-axis is the axis of reflection. Pupils, this line also divides the perpendicular lines that connect all points which join the object and image. The image is the same shape and size as the object. Pupils, let's observe the orientation. Yes, the image has reversed orientation and forms mirror images with one another. Therefore, we can conclude that the object Q is reflected in the y-axis. Girls and boys, now let's solve these together. Can you draw the image of the triangle ABC with a reflection on the line PQ? Try it together with me. Sketch the image and line of axis on your grid paper. Step 1. We need to select any vertex and construct a perpendicular line from the vertex to the line PQ and extend beyond the axis of reflection. The perpendicular distance of the point from the x-axis of reflection must be the same. Step 2. Draw parallel lines to all other vertices. Step 3. Determine the distance of each vertex from the axis of reflection and mark an equal distance from the axis to the same line. Do the same for all the vertices. Step 4. Label the vertices of the image and draw the image. Well done, pupils. We had looked at the properties of reflection and drew the image under the transformation of reflection. Well, boys and girls, it looks like we have come to the end of the lesson. Now, you are able to recognize transformations and translation, describe translation by using various representations including vector form, determine the image and object under a translation and solve problems involving translation. Recognize reflection. Describe reflection using various representations and determine the image and object under a reflection. I hope that you have enjoyed today's lesson. Thank you very much for your attention. Goodbye.